All right, ladies and gentlemen, let's go ahead and look at our problem here. Your answer should be 21.3 repeating, 21 and a third. So let's talk about why that is. What is our correct setup? So this one is in terms of y. Since we are in terms of y, are we doing top minus bottom or right minus left? Which one is it? Right minus left. We are in terms of y. So we need a right minus left when we do our integral. What is the right-hand equation when we're looking at this? Which one is to the right? The linear, right? So that linear, 2y plus 4, right? 2y plus 4, that is our linear equation. 2y plus 4, that is the right. The left is that quadratic, which is our 1/4 y squared plus y plus 1. That is the left. Okay? So, our integral, what is going to be the bounds of our integral? Where do we do our integral from? We're getting that from the y-axis, correct? Again, we are in terms of y, so we should be pulling our bounds from the y-axis, -2 to 6. And then our right, so that's going to be 2y plus 4 minus parentheses 1/4 y squared plus y plus 1 dy. Please make sure that you are typing it in like we wrote it. Now, in the TI calculators or the Casio calculators, you do not need to use the variable y. You can just use the variable x. So everywhere we see a y up here, just use the x. If you're using Desmos, you can use y if you would like. That is fine. You can type it as we see it. But we need to make sure that you have the parentheses. If you do not have the parentheses, especially on the second one, your calculator is only going to be subtracting or making the 1/4 y squared a negative. You have to have that negative in the parentheses because every single term is negative. All right? So again, the answer for that one is 21.3 repeating. Now, I had a couple people that got a negative, but the numbers were the same. They just got negative 21.3. Your area, when you're doing areas should be always positive, not negative. When you're doing these calculations anyways, area is going to be positive. If you get a negative area but the numbers match, what that means is that your f and your g, your two equations, you had reversed. So if you had done the quadratic minus the linear instead, you would get the same number, but it would be negative. So if you do all your calculations, you come out, it's negative, you match you look at the answer, it matches, but if your answer is negative, you need to flip your equations. You did a left minus right or a bottom minus top instead of top minus bottom or right minus left. The order does matter. Okay, guys? All right, so what we are doing now is problem number 6. This is also Calcul-Out, so have your calculator. So we have problem, or let R be the region in this first quadrant, bound by our x-axis, natural log of x, 4 minus x. Find the area of R. So we're going to do this twice. First, going to do it in terms of x. Then we're going to in terms of y and see, do we get the same result? Hopefully we do. Okay? There are some instances like this problem that we could end up doing it either way in terms of x or in terms of y, and it will not matter. Now, there are going to be instances where maybe one is better than the other. Or there are going to be problems like we saw yesterday where one is not a function of x and we have to do it in terms of y. All right, so we're going to be doing in terms of x first. If we are in terms of x, is that going to be a top minus bottom or right minus left? Which one is that? In terms of x, which one is that? All right, so let's look at the top minus bottom then. Okay? If I do top minus bottom, what is my top? If I draw a line from here down to here, what is my top equation for that little line that I drew? What's the top equation? The natural log. Pretty obvious the natural log is the curve, right? So that's my top. What's the bottom for that little segment that I drew? So I have my top, that's natural log. What is my bottom? The x-axis, 0, right? Now, I can draw these little segments showing that top minus bottom, natural log minus 0, all the way. So notice I'm not using that linear yet. But what happens here? They meet, so I have a point of intersection. But then as I go past that point of intersection, what is my top now? The linear, which was what? What's that linear equation? 4 minus x, yeah. All right, so that's the 4 minus x. And every place past that point of intersection, we're going to be using the 4 minus x, and my bottom is 0. So looking at that, what would we need to do to set up this area? What would we need? We need how many integrals? 2 of them, right? We're going to need 1 for this red chunk and 1 for the blue chunk. What are going to be the bounds of those integrals? So for this first one, the red, what's going to be our bounds? 1, 2. It's not exactly 3. If you look at that, it's 2 point something right here. It's not 3. If you use 3, it's going to be wrong. What are going to be the bounds of the blue integral here? The b to 4. So, what do we need to do first? How are we going to find that intersection? Graph both functions, find their intersections. So that's just why it's a calc-aloud problem. So go ahead in your calculator, graph both, find their intersection. That is going to be your b. If you would like to store it, you most definitely can. All right, so what is our b value, guys? Where are we intersecting? What's the x value there? 2.9 what? 2, rounding up about 2.6 or something. Okay. It might be 2.7, 2.5. All right, so what is our integrals going to look like? We have 2 of them. What's our first integral? Integral from where to where? 2.926, or 1 to b, of what's inside my integral? ln of x dx. And then what are we going to do? Plus. These are 2 adjacent areas, so we're adding them together. What is going to be the bounds of my second integral? To where? And what's inside my integral? 4 minus x, and I close it with dx. All right, so go ahead, if you haven't already done so, plug that into your calculator, store your answer, your number if you would like, and what is our area? All right, what is our area, guys? 1.792. All right. Do we all agree with that area? Is that what we're getting? Okay. All right. In terms of y. So in terms of y, that is a top minus bottom, or right minus left, or left minus right. What do we do for in terms of y? Right minus left. And if I do a right minus left, what is my right? What is my left? Will I need one or two integrals? Just one. So this one, maybe in terms of y, might be more efficient because we only have one integral. Okay? So our 4 minus x is our right. However, we need that in terms of y. So how are we going to solve that to be in terms of y? Yeah, so how would I isolate x? I could subtract the 4, then divide by -1. I could add the x, then subtract the y. Either way, what do we get? X equals what? -y plus 4, or 4 minus y, which actually ends up being pretty much the same exact equation. It is itself inverse, more or less. All right, going over to this one, we have y equals ln of x. So how do we solve that one for x? What do we do to both sides? Exponentiate, so we're going to exponentiate, so x equals what? E to the y. Now, could we graph e to the y and 4 minus y and look at those? We could, or we just use the same graph that we already have. What are the bounds going to be? 0 to something up here. Did you guys pay attention to what the y coordinate of that intersection point was? 1.0. I have 7.4. All right, I want to show you a trick. So I think I have them in here. Okay, graph, there they are. All right, so we're calculating. That's nothing new. That's not a trick. Bam, bam, bam. All right, there we go. So 1.0737289. Now, that is an x, right? Or that's a y, sorry. If you go out here, I showed you how we can do x equals, and there's the x value. If you do alpha 1, get the y, guess what's stored into y? The y value. So if you take that y value, you can then store it. I'm going to use d, store it into d, c to d, right? So when you find a point of interest, any point, when you calculate a point, the calculator will automatically store it in x and in y. The y is down here with the button number 1. So you can store the y value as well. If you're in Desmos, you can just copy and paste that y value in the coordinate pair. All right, so going back here, what would be our integral then? So the integral from where to where? 0 to where? 0.74. What is inside? What is going to be my inside, my integrand in there? 4 minus y minus, it's my left, e to the y, dy. All right, I want you guys to plug that one in. Check to see, do we get the same thing? If you did everything right, your area should be the same as what we got in part A. All right, do we get the same area, ladies and gentlemen? Yes? All right, 1.792. And there we go. So again, as we see demonstrated in this problem, sometimes we might have a problem where doing in terms of x in terms of y, each of these wasn't that much extra work, but doing in terms of y might be a little bit more efficient because we only need one integral instead of two. But either way, it gives us the same area. All right, let's go ahead and turn the page and continue with our notes. So day 2. Thank you. So right here, we have this region. It's being kind of split into 2 parts right there, right? So I want you to consider it and think in your groups, how would we write out our integral expression that would give us the area for that? What would that look like? What would our integral look like? Would we need more than one? Would we be able to do it with just one? Talk in your groups. Think about how we could find, what would we need to do to find that total shaded area altogether there. All right? Give you a minute or so. All right, ladies and gentlemen, what are your thoughts out there? How do we do this? Would we need one integral, two integrals, 5 million integrals? What do we need? 2 integrals? Not 5 million, you sure?
I have 2.
5? 5 million? All right. What would be our first integral? Yes, we need 2. What would be the first integral, guys? A to B. All right, we see A to B. What would be my top minus bottom? What's the top for that first chunk? G minus F. So G's on the top, F's on the bottom in that one. So that would be G of X minus F of X dx. All right, what would be my second integral? B to C. All right, so we're going B to C. And then what's our top minus bottom there? Good, F. So that flipped, right? In the process of doing that crossing, the top minus bottom got flipped. And again, you have to pay attention to your order. As if you don't have the correct order, things will not come out correctly. So top minus bottom. So that would be our correct order. Now, if we are in terms, so that's in terms of X. If we're in terms of Y, it'd be in a very similar way. You just think right minus left each time. Okay, so that, you guys are totally correct, is what we do with that type of problem. So I want you to try it in problem number 1. In problem number 1, we have our 2 equations. It is calculator allowed. So you're going to use your equations to figure out those intersection points. Where do we intersect? You need all 3 of them. And then you need to also determine what is the top, what's the bottom for each of those regions. So go ahead and use your calculator to do that on problem number 1. Give you a few minutes. Okay, one thing I want to note on your TI calculators or Casios, it can happen on any of these. Desmos tends to not do this. If you have an intersection that looks like it's at 0, which like that one looks to be at 0, and I'll tell you it is at 0, okay? Sometimes the TI calculators, and this can really differ from calculator to calculator. I had 2 TI calculators right next to each other that were doing this. One gave the value as 0. The other one gave the value as 5.2 e negative 15. What that means is 5.2 times 10 to the negative 15. What do I do as scientific notation when I have that? How many times do I move that decimal place to the right, to the left? So that means I'm going to have 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 5, 2. When you see that, it's just 0. Okay? Now, I had another calculator in second period that wasn't 5.2. It was the same exact problem. The calculator said, oh, I think it's 1.7 times 10 to the negative 15. Okay? Either way, that's just 0. For whatever reason, from calculator to calculator, it kind of differs in the way that it calculates the 0. And it could calculate it as that. We're not going to, that's way too many zeros. That's just 0. All right, guys? So if you do see that, just treat it as 0. Input it as 0 when you do your calculations. Okay, I'll give you another minute or so to finish that one up, and then we'll check in. All right, let's go ahead and do this one. Where's our first intersection point? What's the x value? -2. Middle is 0. What is the right? The third one? +2. That came out nice. All right. For the first interval, which one is my red? Because that's my top. Is my red the F or the G? Is it this quadratic or the cubic? The red one right here. That one is F. So the bottom is G. So for my first integral, what's my first integral going to look like? The integral from where to where? -2 to 0 of my f of x minus g of x. So I want to point out, does that necessarily match with what we had up there? This first one and that first one, do they exactly match? No. So you can't just say, oh, it's F and G, so I'm going to follow this pattern every single time. So that's not necessarily what it's going to be. You have to pay attention. What is the top? What is the bottom? And you need to make sure that's being inputted correctly. What is my second integral? Oh, I forgot my dx. dx. What's the second integral, guys? 0 to 2. What is my top on the second portion? G. What's the bottom? F. So that's going to be g of x minus f of x. All right, what did you guys get for the area? It was a nice whole number. What do we get? 16, not -16, +16. Any questions on problem number 1? All right, I want you to do the same thing, problem number 2. Calculate this one. All right, ladies and gentlemen, answers should have been 2.760 if you did everything and set it up correctly.